So setting the stage, the introduction for this, we're going to talk a little bit today about communication with our customers to help avoid things coming up in the future. We always want to look at this in order to, we call this the 7 habits of highly effective electrification people. And it's really obviously stolen from Stephen Covey, but it really it encompasses what we do. And the big part is beginning with the end in sight. Everything that we do has a plan. We want to look at the entire process of each home's electrification pathway and really design out the whole journey for each customer. Everyone is unique, even if the houses are the same. It's very strange. Putting first things first is really important as well. Doing things in the right order, and we've addressed that in some of our other webinars in the past. And we want to do things in the right order, because if we get out of alignment, if we insulate our attic before we put our system up there, it just causes a lot of problems. So we just want to take things in the right order. We want to think win-win. We want to win as contractors and be able to make a profit and feed the families that work for us, but we also want our customers to win with good, efficient systems that are well thought out and well planned. So we try to be very thoughtful about all of these projects that we do and make sure that the customers and the homeowners and the people that are trusting us to do systems for them are getting what they're actually being delivered what we talked about. And it doesn't always work that way, kind of with the box replacement industry that we're kind of living in. So taking a thoughtful approach helps with the win-win. We help our customers understand what we're going to do, and we understand where they come from. So we design systems around that. We synergize, and we always tell our customers to go out and sharpen the saw, do a little research, find out what you need to know about it, and back up what we're saying with other research as well. So this has kind of worked out well for us to design our approach this way. So as we know, as contractors, we can do very well and have good profit margins and put jobs in that actually make money and feed the families and pay the bottom line. But what always comes back is these things are out of our control, but they're not really out of our control. They come back when we're not expecting them. And these are these callbacks or go backs or complaint calls. So we look at these in 3 different ways. A callback for us is a return service to correct a problem that was on a project that was already quote unquote completed. These are always preserved as or perceived as an urgent issue, and they always cause a problem with the schedule. Like we gotta move somebody here, do something here, and it just creates a lot of chaos. So trying to take care of this stuff up front is really the best way to prevent this. And what we're trying to avoid at all costs is a upset or disappointed customer. Nothing changes my total focus and the way I feel about the way the day is going than hearing that one of my customers for some reason isn't getting what we promised. And it happens once in a while. It's pretty rare, so I should be thankful, because we're pretty blessed. We do things mostly really right all the time, as much as possible. And then we have the go backs. The go backs are just that additional time that's required. We have one going right now that we were going to remove the flue pipe from the outside of the house, and we didn't take a long enough ladder out there on the last day. So we have to go back Monday and remove a flue pipe, which means I'm pulling a guy off a job. It's just all this juggling that has to happen with these. So that's go backs, what we talk about those. And then complaint calls. The complaint call is when we get that email from the customer whose system is not meeting their expectations. And when I get one of these, what we usually find out is that there's some sort of a mechanical issue. It's usually not a design issue, because we spend a lot of time designing these systems to work well and be installed well. But sometimes we have like a defect in a piece of equipment, or a board goes bad, or just some issue there that's creating this complaint call. But, you know, once in a while we get a legitimate complaint call where we have to balance airflow or something like that. But so we break these up into 3 different categories when we're tracking them, so that we can figure out where the money's going. We've taken the time to really go through and figure out how much a callback costs, and we try to look at this once a year. This is our newest iteration of going through this. We were figuring last year a truck roll was about $325. Now it's a little bit more than that. So a lot of the way we do our service when we do rollbacks is we will have one of our teams stop by on the way or the way back to take care of a problem. And usually I've got a team in the truck, which means 2 guys. We do have a dedicated service tech that can go out and take care of some of this. So the cost to roll that truck's a little bit less. But when we're looking at 25 miles both ways and labor in traffic, you know, you're just paying your guys $100 just to sit in traffic on the way there. You got a couple hours for 2 technicians at $30 an hour. More if it's on overtime, and we try not to have that happen. But we have all these costs incurred, and then we look back on it and we're going, you know, where'd that money go? And that money is just spent taking care of customers who were not completely fulfilled or there's a problem. So this is really a big budgetary suck at the end of the job, right? Something that we're not preparing for. We look at the job costs, we say, look, we made money on this. And then we look at the times we went back and go, oh, guess what? We maybe didn't. So managing these things is a really important part of running the business. And we're still like working on it totally. So we're going to share the way we do this. So I'm losing money on callbacks. What can I do about it? First thing to do is try to avoid them, obviously, and we're going to talk a little bit more about that. And number 2 is learning from them. So we're keeping a running list of the callback issues and trying to keep them categorized for the most part. We got a couple of people looking at this, trying to do a better job at that even internally at our place, but it's on our radar, and we're trying to collect this information so the mistake doesn't happen twice. We keep notes about how we solve these problems and how they could have been avoided, and then we share that with our staff. We have meetings regularly where we talk about things that went really right, and then we talk about the things that went wrong. I try not to ever start meetings with what's going wrong. I always want to elevate my staff and let them know how appreciated they are, and then go, hey, we could do better here, right? Picking out the themes and the most common issues, we've been able to work through a lot of the common issues and just kind of eliminate those from being problematic just by everyone knowing that these are the things we really need to take care of. But then we'll find another common thread pops up later. But the other thing is giving that feedback to all the members of the team in a very constructive way. We try to always have all our team meetings with a very positive front half of the meeting, go over all the good things that happened, and then kind of debrief on what's going on. And we let the technicians debrief, and we talk to them and try to bring out in front of everybody what these issues are, so we can learn from each other in the company. And that's been quite helpful at minimizing a lot of this problem in our company, at least. So what we found, though, is there's a lot of these problems that are popping up just because customers are not familiar with the technology that we're putting in. So we're really good, and we're really dedicated ourselves to making sure that we understand our customers and our customers understand what we're doing. We always ask our customers when we're doing our virtual assessments with them, like, how do you use your existing system? And we take that information and we transpose that back to them as how their new system is going to work differently. And we make sure that we get buy-in from them. A good example, I can remember one customer last year, house with a lot of windows, several bids out there, and we asked the customer on the virtual assessment, like, how do you use your furnace? And he said, well, we turn it off at night. The house often gets down to the mid 50s, and we turn it on in the morning. It was a really big furnace, so they take the chill off and they kind of coast all day with sweaters on. And I says, well, that's not the way the heat pump is going to work. Did any of the other companies that came out talk to you about how different this is going to be for you? And they hadn't told him anything. But I was able to get his buy-in. I says, okay, so the way that this is going to work is we're going to have to keep your house warm when it's cold outside in order to not use a lot of energy and give you comfort or lack of comfort that's not going to work for you. So is it okay, and are you agreeable to keeping your house warm when it's cold outside rather than the way you're doing it now, which is kind of taking the chill off in the morning? And we got their buy-in early. Like, we spent time talking to the customer about that, so they know what's going on there. And should there be a problem, would they ever call me, I can revert back to that. Do you remember when we talked about how differently this system would work? We have found that has been amazingly positive in the way the customers understand how their systems need to work. We also asked them, why are you interested in transitioning to a heat pump now? And a lot of people are doing it because they've read, or their neighbors have got one, or they just want to do what's right by the environment. And that opens up another conversation, right? So what did your neighbors tell you about their heat pump system that made you interested? Do you know that by moving to a heat pump for environmental reasons is going to give you what you need environmentally, but it's going to change the way you're going to have to use your system, and is that okay with you? And we always ask them as well, do you know that with a heat pump system, there's no longer just going to be a furnace in your basement or your attic. We have to have a system that goes outside somewhere, and have you kind of thought about that part? And we don't always end up putting them where the customer might think they are going to be, but we get a lot of intel on this, and it just opens up the conversation, and it'll bring back a memory when we're doing our on-site visit for the customer. And that's been really helpful to kind of reduce the, I thought it would go here, no, can it go here? Because we talk about the things like the setbacks and the noise requirements and things as we're talking about the system. So no surprises is a good way to avoid some of this. Most of our customers, their starting point is they've always lived with a gas furnace. They've always lived with a gas water heater. And most of them have never lived with a heat pump like we're going to install. Maybe they lived outside in the outskirts of town, out past the gas lines, and they had a heat pump at some point. But most of them have not lived with the type of systems we're going to be installing. And heat pumps come in a lot of shapes and sizes and different models and different performance factors. There's just all these different things about them. We mostly put in heat pumps that are, if you've watched any of these classes before, inverter style equipment, self-modulating, self-adjusting systems that can work no matter what the time they're trying to use them in real time. So they're going to be a little bit different to operate. You can't wait. If your house is cold in the morning and it's really cold outside and you turn one of our heat pumps on, it's going to take a long time to heat up your house. They have to understand that they need to keep the house warm and tempered so that the unit doesn't have to work as hard to make up the little gaps in temperature. And interestingly enough, if we look at this picture here on the side, this is a filter right here, and they mounted a pump right in front of it. So I just happened to notice this when I was looking at the slides earlier, and this would be an actual good slide to show if we were showing how not to install a system. Like, you would have to disassemble this whole thing to replace this filter every time. I thought that was kind of interesting. So comparing furnaces to heat pumps, we don't want to be afraid to explain the differences in operation. And so we do a lot of training around, and we get to talk to a lot of contractors one-on-one that are just kind of getting into this whole heat pump thing. And we get guys that come in a lot, and guys and gals, and they come in and they talk about, hey, we're putting these heat pumps in, our customers just aren't happy, their bills are high, they're not getting the heat they need. And we go to, did we spend enough time setting the expectations with the customer so that they understand what they're getting into, first of all? And some of the companies are like, well, we don't want to tell them that because then, they're not going to buy it from us. So our whole thing is just like setting expectations up front is going to be so much better than having to deal with a customer later that's not happy with what you did. You got to start on the right foot with these things. So don't be afraid to explain the differences in operation and really get in there and be granular in those expectations. Like when you know it's going to be cold for a week, you watch the weather report, you need to turn the system on while the house is still relatively warm and just maintain that warmth. That's going to be the most efficient, most cost-effective way to keep your house warm. And don't turn the thing down 6 degrees at night when you go to bed, unless you want to wait an hour and use a lot more energy the next morning trying to warm the house back up. So furnaces, you know, they have a lot of capacity to create heat, so much capacity, in fact, that most furnaces in California for sure are just grossly oversized. And those oversized furnaces do one thing a lot pretty well, is they heat houses up relatively quickly, but they're also wasting a lot of heat. There's a lot of waste heat, so the customers don't understand how inefficient their building envelopes are, how much leakage there might be, because all this waste heat kind of covers it up. So we're talking to our customers about that. Like, we are going to reduce your heating capacity significantly with this system. There are other measures that we need to take to make this successful for you. So we also talk to them about, you know, don't turn it on, don't turn it off. Leave it on when the weather permits. You don't have to run it 24/7, 365, but you do want to stay warm in the winter, and you do want to stay cool in the summer. So just be proactive in the way you operate the systems. We explain the heat pump longer cycles, moving heat, air temperatures that are much closer to room temperature. And we reframe these, what could be considered negatives by some customers that have had furnaces. We reframe these into positives. Like, my longer run cycles are now better opportunities to clean the air and mix the room temperature. The idea of putting the correct registers in the house so that the air doesn't blow directly on the customer. This is all very important stuff. Heat pumps are going to cycle much longer. And, you know, the benefit is they're not going to have any on-site pollution. This is what most people are looking for, but we're just trying to reframe those negatives into positives. We really want to emphasize comfort. The comfort you can gain from a properly installed heat pump system is that your house will feel warm when you want it warm, and it will feel cool when you want it cool. And most of the systems we install, you're not going to hear them operate. So we have had customers think their systems are not operating, and we have to say, well, what temperature is it in your house right now? That's probably running. If you're comfortable, it's fine. But they're so used to hearing these big machines run all the time that having a nearly silent system is kind of foreign to people. Most people don't understand what real comfort is until they've had a really good system installed in their houses. When you hear a customer say, you know, my house heats up in 5 minutes, I got a great furnace, my house heats up in 5 or 10 minutes. That is not a great furnace. That is a grossly oversized system, and that's not comfort. We were just talking to some of the folks that are in our class here this week about this perceived comfort, and the idea that we call each other comfort advisors, and then we install systems that don't really provide comfort. They provide heat when it's cold and cold when it's hot, but they don't make houses comfortable necessarily. So we emphasize how much comfort they're going to get out of these systems, and that helps offset the perceived negative of the systems running longer. So we also use analogies to let our customers know how this is going to work. This is a different type of system. It's like going from a combustion vehicle to an electric vehicle. If anybody's ever driven or ridden an electric car or a Tesla or one of those, we know that the experience of driving that vehicle takes some getting used to. It's very different, but it's really great. And so saying now your home is going to operate more like an electric car. It's not going to be as quick off the line as the other one is, but the longer we run it, the more efficient it's going to be. It's going to take a little bit different control. It's going to be quieter, and it's going to be more energy efficient. But we have to understand how they're going to work. Another good way to explain it is incandescent lights versus LED lights. Paper maps, or the Thomas guide versus a GPS. I know as a man that's quickly approaching my 60s, I don't think I could use a Thomas guide anymore. You can understand how small the print in it. They were fine when I was in my 20s. I don't know if I could do that now. So explaining the different heat pump options to our customers as well. We're pretty we're pretty set in our ways as far as how we install most of our inverter heat pump systems. We like ducted systems very much. People are really used to ducted systems. They're not used to units hanging on the wall. We're not used to having a separate system in each room. But a lot of the customers come to us thinking that's what the option we're going to recommend is, because they've done research online, they've gone to the various manufacturer websites, and they see the unit that goes outside and the unit for each room or unit on the wall in each room. And some of them are expecting that quote from us. So we have to talk to them about the inefficiencies or the deficiencies that they will get with one system or another. So the other thing is we try to discover as much about our customers by asking several questions up front. And then when we figure out what our customers are most concerned with, we spend a lot of time developing conversations and letting them know how our system is going to fit their needs. One thing is we don't do is we don't waste a bunch of time talking about things that don't matter to our customers. Our virtual sales process is designed exactly for this. We will look at a reaction from a customer off of a picture that we're showing them on the little webinar that we do for each customer. And depending on their reaction, we'll go into more or less detail on that particular item or accessory or whatever it might be. We use pictures of real installed systems to show what we're talking about. Line cover, line sets going around the walls. If a customer comes in initially perceiving that we're going to put 5 of these units on the wall, 1 in each room, I'm going to tell them there's going to be a lot of material that's going up the sides of your houses that you're going to see, that it's going to look foreign to you. We just don't want the installers to get out there and start putting this stuff on the side of the house, and then the customer goes, what the heck is this? We use pictures and we set expectations for that. It's another way we avoid that kind of unsatisfied customer callback. A lot of the customers we talk to, because of what they've read online, really think that the one-to-one room solution is best. And they get that because, I'm not always in my office. My kids aren't always in the bedroom. We're not always in the room, the great room. And they think that this might be a great option. Well, when we look at this option and we look at what needs to be done to put the systems together, and we talked about this in previous lessons, but if we have 5 of these units in 5 different rooms in the house, we have to put a system outside that's large enough to carry the capacity of all 5 of these units. Typically, when we're doing load calculations, we're finding out that smaller bedrooms and things might only need 15 to 2,500 BTUs in the design conditions of the year. In other words, the hottest and coldest days of the year. A lot of these manufacturers don't make systems for these single walls that are lower than 6,000 BTUs. Some manufacturers only go down to 9,000 BTUs, which means that I'm putting a much larger system in each room than I need. And when I do that, I have to calculate the total capacity of all of these and get a system outside that will run all of these. And it makes it much more difficult to size a system for the house that's going to be right. And it means that we have to put a much larger system in the house than it needs. So it's just waste. So this is one of the reasons why we like the ducted version somewhat better, is because I could take care of multiple rooms with one unit. There's less infrastructure involved, and I've got more of a balanced airflow and getting each room exactly what it needs. One of the major problems, we'll just touch on this for a second, when we're doing this zoning with multiple heads on the walls, and we're sizing this outdoor system to the capacity of multiple heads, these units here, they will modulate up and down. They'll give you a lot of heat when you need it and a little heat when you don't need a lot. But the problem is they'll only go down so far. So if I'm putting 5 of these heads on, and let's just say they're all 9,000 BTU, so 5 times 9 is 45. I think I got my math right on that. I would need a 45,000 BTU outdoor unit. Some manufacturers don't do that, so we'd have to go up to a 48 or to a 42, depending on where we're at. Still, that may be way too large for the house. So what happens is that system may not be able to modulate down far enough that when one of these units is running, it's not going to be running full blast all the time. So like I said a second ago, a lot of the houses we find maybe need 1,500 to 2,500 BTUs in that room. And if I have a 6 or a 9,000 BTU head here, and it can't go down any lower than that because it's the only one running, it's going to make that room extremely hot or extremely cold and not comfortable. So we explain to our customers, if you're going to do a system like this, you're not going to just be able to run one at a time. So if that's the reason you want one of these, it's not going to be a good match for you. In fact, in most of these systems, we would need to run 3 of these in order for them to be able to modulate. So that's something to keep in mind with this. Zoning needs to be done really carefully. We will expand on this in our next webinar next week. So everybody in the whole chain is responsible. All members of your company should be responsible for setting the expectations with the customers. I do have all my guys trained really well to deliver the same message. Like everybody knows what we're doing and why we're doing it and how they work. Some of the younger guys might not explain it quite as well as the guys that have been doing it for a while. But all of my guys get intro training on the basics of heat pumps. Everybody at your company should understand what's going on. So when that customer corners one of them somewhere and asks them a question, they don't say something that's going to cause that customer to pick up the phone and call you. The CSRs in your office, we've noticed as we were going through and building this, we need to take a little bit more time with our CSRs on a couple of things, not about this, but some other stuff. But the CSRs should be able to field the most basic questions about operations. Like if a customer calls up and says, my system isn't working, it's 63 in the house, and we know it's 39 degrees outside, my CSR knows to ask, did you turn the system on when the house was warmer? When did you turn it on? Just to find out if there's a problem with them not running it properly, or there might be an actual mechanical problem with the system. So they're pretty good at asking those questions and figuring out that and directing the traffic in the right way. The dispatcher, the customer should know what to expect from the visit. My dispatchers are going to tell them, they're really good at that. Like my technician's going to be here, he's going to check this, and we're going to turn the system on before we get there so we can see it in full operational mode. And then deliver that information to the customer so that when my technician gets out there, the house is, it's been running for a while. We know if it's actually working or not. The dispatcher also needs to know who inside the company to contact if technical questions arise. We use Teams in our office. It's really effective. So the dispatcher will shoot a Teams chat over to whatever person in the company is necessary to answer that question. Our accounting department is looking, the dispatcher in the accounting department is looking at the rates of callbacks and kind of running red flags like, look, we've had a couple of problems here, we need to look at this. And they're kind of doing that in the background, just looking at the numbers and where things are going and what the hours are. Like, why did we have hours on a job that was completed 5 months ago? Why did we suddenly have hours on this? And then that will trigger at least a conversation internally. So salesmen, the salespeople, the comfort advisors, the system designers, whatever you call your guys at your company, this is where the rubber meets the road. This is where the explanations need to happen with the customer up front, and we need to really we need to make sure our customers understand what they're getting, what it's going to look like, how it's going to be operated. Everything up front should be done before we execute a project. There should also be a happy call once the job is done. So I, as the owner of Electrify My Home, I probably do happy calls on 20% of the customers that we do. And then we have someone in the office that's calling after it's been installed a couple of weeks, just to make sure that everything's okay and the customers are happy and situated. A lot of times though, what happens, everybody gets busy. This happens at all companies. And we really use our quality assurance is, did the customer call us or not? And we want to try to stay away from that as much as possible and make contact with that customer. But I mean, we have challenges with that as well. The technicians need to do a detailed walkthrough and thermostat training when the system is installed. These thermostats on these systems are not like that Honeywell thermostat or that Nest thermostat. These thermostats need to be set up properly for the proper airflow. The technicians need to go in and make sure all of that's set up properly, and then walk the customer through how to operate the system, set it up for them in the way that they kind of understand they might want it installed or set up the first day. And then we as owners and general managers, we need to empower our teams to head off the issues. And this is going to be like training and feedback loops. We've got the feedback loops working pretty good in our company. Like when my dispatcher or my CSR gets a call and it's something that they can't handle, they are chatting with the next person right away, trying to see if they can get that problem solved instantaneously. If they can't, they're letting a few people know, and then we're all in the same chat so we can see who took care of it or if somebody didn't, so we don't have 3 people calling the customer, and in the worst case, we don't have anyone calling the customer. So those feedback loops are very important as well. And sometimes we know, like, the customer isn't just one person. So there's spouses and families, rental houses, like, you know, how do you we put a small system in that needs to be operated a specific way. This customer moves out of that house and turns it into a rental house. That is always going to be a phone call. There's always going to be a phone call to my office. This has happened several times where the new tenant calls the landlord, says the system isn't working. The landlord says, call these guys and have them figure it out, right? Or we get a call out there. We're trying to work on a way to figure that out. And maybe sometimes it's leaving a little, just a little one-page guide on best practices on how to use your system, and have the landlord leave it there. There's also architects, contractors, and designers. So we're working behind the scenes to build these great systems, and then we're going and installing them in a house where we really haven't had a lot of contact with the customer other than letting them know they're getting a heat pump and it's going to be an efficient one. So we need to do that same instruction with that person once they move into the house. We're going to end up doing it one way or the other. We can do it proactively, but sometimes we don't know that this is all going on, or we're going to do it reactively when that customer calls. But one way or another, they're going to have to figure out how to use these systems, or the first cold morning, they're going to be going, what the heck is going on here, right? So we've created some basic user guides for system operation, and they're very simple, but getting them into the hands of the people that need them seem to be the biggest hurdle. So we're trying to work on that as we go, but keeping this stuff in mind is going to help reduce that. So this is 5 things to tell your customer about their heat pump to avoid callbacks on HVAC installs, on the heat pump system installs themselves. One is understanding the $400 callback cost from earlier. Yours might be a little bit less, but that $400 callback cost, if you could avoid that just by thinking of these 5 different things that take 10 minutes, would it be worth doing? I would certainly do anything for 10 minutes for 400. Well, within reason, I will do most anything for $400 in 10 minutes. Now you know what my price range is. So thermostat operation, this is the big one. Relevant to heat pumps, ducted, ductless, multi-zone, it doesn't matter. The customers need to know how to use these things. We design our systems to, and most of the time when we design our systems with our load calcs, our fan energy or our fan speed or our delivered cubic feet per minute of airflow is usually going to match the high speed setting of the system. But we don't necessarily tell the customer to run the system on high speed, because they're not always running their system on design days, right? It's not always the hottest and coldest days of the year. So, and I do this in my house too, I keep my fan system on automatic with my inverter heat pump, and it kind of varies the capacity. But when it gets really hot outside, I use the high speed fan in that system. So it's always running in high speed when you set it there. That's kind of like the turbo mode, right? And let's see what I explain it to the customer. If it's really cold and you want a little boost of heat, put that fan on high speed. Same way with the air conditioning side, because the system is really designed to deliver the airflow CFM at that high speed. But it doesn't always need to do that, because we're not, we're a lot of times at partial load. So operational time, we always explain the operational time when we're presenting. I explain the operational time when we're doing our site visit. and we explain the operational time when we're installing and our technicians are there. That customer has been touched 3 times with the idea that the system is going to run for a long time, but it's using very little energy doing it, and don't worry if that's the case. We've also found some customers want like a Nest thermostat or a Ecobee thermostat. And we have had customers that wanted the Ecobee thermostat. We reluctantly put in the thermostat transducer, or the low voltage interface module, hooked up the thermostat. And then I get a text from the customer, and they say, look, my thermostat sent me a thing. It said the thermostat's been running for 5 hours and it's only come up 1 degree. There's a problem with the unit. So this is something we're trying to head off anytime we're doing those too. Is like we need to turn off that default in that thermostat, so it's not sending the customer a message that's ambiguous when it's compared to what we're actually doing. So frequency of adjustment, it's okay to set these things and forget them, especially in the coldest winter weeks. And that's a hard thing to overcome, especially with those customers that just take the chill off in the morning and wear a sweater all day. Like we want the systems, we're designing them to have the lowest amount of energy use possible, and we want the customers to hypermile these things. We want them to leave them on to where the house gets charged up, and the systems run as slow as possible to maintain the heat and not reheat it all the time. So it's okay to set it and forget it. I understand you and your wife like to live in like to sleep in a cooler room. Open your bedroom window if it's safe in your neighborhood to do so. Open the bedroom window, keep that bedroom cool, but keep the rest of the house warm. That's always our advice to the customers. A tempered house uses less energy to get to full comfort. If we let that house get out of temper, we've released all this energy we've put into the furniture, the wood, the walls, and the doors. That's all gone away. We have to reload all that. So that takes a lot of energy to do that. Leave these systems on, let them go, especially in the cold. So avoid setbacks. There's people out there that are used to, we've been told in California by the utility companies for years, 78 on cooling, turn it to 85 when you leave, and run the house at 68 and turn it down to 65 when you leave, or whatever the numbers are. We've always been told to set everything back. And that worked well when we had systems that were way too big for the house. But now we're sizing systems that are actually the right size for the house, and they're working the way they want to. So we have to deprogram the customers a little bit on this and just say, hey, when you go to the hardware store for half an hour, you don't have to turn your heater off anymore, right? You're not saving energy by doing this. Everybody got the idea that setting back the thermostat was saving energy. And that's not the case anymore when we're putting in these heat pumps, right? We want to keep the house loaded with heat. So time of use optimization. It is also possible to save money on operating costs if we're not running our system, or we're running it the least amount possible during the 4 to 9 p.m. kind of peak rate hours. And we know peak rate hours cost a lot to operate. So if we preheat or pre-cool our house and then we set it back for a couple of hours or a couple of degrees during that period of time, we can reduce that energy cost through peak rate. So if a house is fully charged and it's say 70 degrees when they walk in at 4 o'clock, and you've done a decent job putting in your system, your ducts are sealed well, you put some insulation in the attic, the house is performing fairly well, they can turn that unit off for a few hours or turn it down a couple of degrees for a few hours, and then that unit will run in its lowest mode, or it'll kind of turn off during that time. That's okay to do as long as there's an understanding and as long as the system is sized right. But if we have too small of a system in a really leaky house and they turn it off for 4 hours, it could get pretty cool in there and we have a lot of energy coming back. So, but it is possible with a good envelope to really pre-cool or preheat. And then multi-zone, depending on the configuration, run multiple pieces of the multi-zone at one time. We'll talk about that a little bit more next week. So winter operation. We need to talk to our customers about these things, right? So defrost, that unit is going to have some ice on it outside when you walk by it at some point, and you're going to notice that. You may hear funny sounds coming from the outdoor unit, like a toilet flushing. You might see steam coming from the coil. You might see or hear a noise and see the fan isn't running. There's these things you're going to that are going to be strange, but it's perfectly okay to see those. That's the machine operating properly. The noise, you'll be able to hear your outdoor unit on the coldest nights of the year. We talk to our customers about that a lot. A lot of these mini split type systems that we install, they're very quiet when we install them because it's a reasonable temperature in the day. And you sometimes have to go out and see if the fan's spinning to see if they're even on. But we will tell them, you know, these are going to be very quiet systems except the coldest night of the year. The coldest nights of the year, the system is going to have to ramp up just because of the cold temperatures outside. And that's when they're going to be at their highest sound level. It's perfectly normal. Don't worry about it. And it's good. Even unitary systems are going to be even worse because we have the big unitary systems. A lot of them, when the heat cycle turns off, the reversing valve de-energizes and it makes a really loud flushing sound every time the system turns off. That's something we don't really see with the type of systems we do, but that's something you should warn your customers about so they're not calling you about it. So what's that water? We get this one all the time. And so we talk about this to our customers a lot beforehand, and we still end up getting phone calls about it, but everybody in the office knows what the answer is, right? So most of these mini split systems type units, they have a drain kit that you can put on here so we can put the plugs in the drain holes and run the drain. You don't want to do that if you're operating in an area that gets below freezing because it's going to plug up and cause problems. But if we don't want the water on the sidewalk, hooking up the drain and diverting the water off to a different place, but all else, we want to tell the customer that when this unit runs in the wintertime, it's going to shed water. There's going to be more water sometimes and less water sometimes. After a defrost cycle, the whole sidewalk might be wet, and it's perfectly normal. If the customers know this is normal, they're not going to pick up the phone, right? So putting in that drain kit to divert it, but once again, if you're up in the foothills or the mountains where it gets really cold at night, that drain can fill with water, and that water in that hose can freeze, and then the water can back up into the pan. You want to be careful about doing that in those areas. So this is going to be happening when we have high humidity levels in the wintertime, especially. It goes into defrost, or we're just getting normal condensation on these coils. These are operating well below freezing. So heat pumps produce warm air and not hot air, but that's a good thing, right? So we talk to our customers about this, right? One of the reasons we use correct registers in the house is to keep the air off the occupants. We want to keep it along the wall or across the ceiling if it's coming out the sidewall. If we're doing a sidewall register, we want to kind of aim it at the ceiling so it picks up and gets static along the ceiling if we can. But the biggest thing is we don't want to blow the air directly on the customer because that can create a call, right? So, and we also explain during our sales process that one of the most efficient parts of these systems is when they're running at the lowest speed, they're able to maintain the temperature in the house, sometimes with air that's only 5 or 10 degrees warmer than room temperature. Now that's going to feel cool on somebody if it's blowing directly on them, but if you tell the customer that up front, you use the right registers and try to keep the air from blowing on the customers, like we don't ever get any complaints about this, but I hear contractors in our training classes all the time talking about this. So this is a big one right here. Let the customers know how they operate, what to expect, and use the right registers to keep the air off of them. Filters will last, right? We know as being heating and air conditioning people, customers don't necessarily always change their filters out. So one of the things that we do is we put these big fat MERV 13 filters on every system. Another thing that we do to make our life easier is we put the same exact filter on every house. So our plenums are designed to accept these 20 by 20 MERV 13 filters. And so this is what we use on anything. I have a customer calls me, wonders what filter it is. Everybody in my office tells them you can buy them on Amazon, and it's a April Air 313 cartridge media. So they can buy it from us, they can buy it from Amazon, we can come put it in, whatever. The best part about these filters too is in most of the climate zones, these things are going to last most of the year. If we design our systems around these and we have a nice big return air and we have a nice big return air grill, and we're drawing less than maximum rated capacity of these filters across, they don't create much static pressure, so they don't create much problem. So even when they get full and they're kind of dirty, they don't really create that much of a difference. So these filters are a little bit more forgiving. Doesn't mean you don't have to clean them, but so good filters don't have to be replaced as often as the regular ones, but still it's important to replace them at the recommended interval. It's good to send your customers out a reminder, hey, it's time to get the filter changed, whether we're going to do it for you or not, do it. And you know, we have our maintenance offering at our company, like most of you guys probably do. And we do also have customers that call and say, I just remembered I have a filter on a 2-year-old system, right? So that happens. But by putting in these filters with lots of surface area, it can go a long time over recommended and not cause that much of a problem with the airflow system. So really good filters, always use the same one, makes life easy too. So 5 things you don't need to tell your customer, but you should do every time. This is a good one too. So outdoor unit location. So what we see here is a big giant unit taking up half the pathway, and they've got a little garden box here. So they really restricted the airflow here, or restricted the ability to like move a wheelbarrow through here or anything large. But the right system on this could have been narrow and much closer to the house. But location is key. We got to talk about this to the customers right away. If they've got limited space on the side of the house, but it's within the setbacks, we want to look and see if there's neighbors' windows close by. Like, do you have a good relationship with that neighbor? Do you want to tell them that you're going to put this system out here? So you don't get that call that like, my neighbor's complaining my system is loud, right? Avoid placing these next to a bedroom, or at least have the customer help you make the decision that that is where it's going to go, with their full knowledge that on the coldest day of the year, you're going to hear this thing, and you're going to hear it. Don't block walkways if you can help it. Save on line set by locating it nearest the air handler you can. You know, we're all kind of focused on that. And consider hanging them on walls and putting them up a little higher. If you've got a walkway in an area that's got setbacks, and we put it 6.5 feet off the ground, it doesn't matter, they can walk right under it, right? However, they walk under it during a defrost cycle, it is going to be a cold shower. Proper line set run. This is really relevant to all the heat pumps, but tell the customer where the line set is going to go and walk them through it when you're doing the site walk, what it's going to look like, what the covering material is going to look like, and that they're going to see it. Because if you come back, I don't know if we have that picture in this webinar, but I have a great picture of a 5-zone unit on the back of a beautiful house, and they've got all this channel going up all over the house. And looking back at that as an HVAC installer, you'd look at that and go, wow, what a beautiful job. But walking up on that as a homeowner with all this stuff going up the side of the house, I would go, what the hell is this, right? So we just want to make sure our customers are fully understanding what this is going to look like, where we're going to go. The other thing is we want to make sure that we put the foam in the outlet of this thing. So we learned this one the hard way a couple times. We need to make sure that rodents can't get up inside these things. So you need to put the foam up inside the termination area. There's that picture. Alex is good with this. Oh, I was looking at the other picture with the brick house. This is worse, right? And you might want to tell your customer if they're going to get 5 individual systems that you're going to hang them all over the house. But yeah, this is the one I was talking about. It's like, this is a beautiful house. If I drove up the driveway and saw that, I think I would go, did that guy tell me it was going to look this way? So just set expectations, right? Do that. Make sure that when you're going through at the tips and where all of these are penetrating the walls, that we're foaming that up and sealing that wall penetration. And make sure that your line sets are sealed or are supported properly as they come out of these, so the line set doesn't rub up against the wall and cause a leak in the line set. So all these little things are learned from experience, right? So number 3, evacuation and charge. This is perhaps the most important thing, especially when you're using this type of equipment. And we learn this in different ways, right? So for years when I was putting these things in back in the day, I was using my vacuum pump, I was running it through my gauges, and it was taking a long time to evacuate as a problem. Now we got these great systems available where we have these 1/2-inch vacuum hoses, and we can put 2 of them on, one each port. Take the Schrader cores out of the ports, put these units on there, use a vacuum gauge that's attached to that, and don't run it through your gauges. The evacuation works so much quicker and better if you don't do that. And then also, when you start the unit up, you're not going to have all that refrigerant kind of locked in your gauge hoses. So use a proper core removal tool, perform the decay test, right? Evacuate it down, let it sit, let that evacuation decay, let that climb up, break it with nitrogen, pull it back down so that nitrogen is going to pull out that additional moisture. And it'll do that at least once or twice during the evacuation, and you're going to get a much lower hold. Otherwise, you're going to get down to some numbers and it's going to keep going back up again. So we all know how to do that, right? So ensure the vacuum holds the lowest pressure for 20 minutes after stabilizing. Charging, follow the charging charts. These units, we don't want to put refrigerant in these units when they're running, and we don't want to ever add refrigerant to one of these units we just don't want to add refrigerant to them. Because one thing, when you hook up your gauges, if you come out to a service call on this unit, you don't know what mode it's in or what speed it's operating in, and they will change speed while you're looking at them, and they will give you some ambiguous pressures if you're trying to judge those pressures against a traditional single speed system. It's not going to be the same, and there's just too much opportunity to screw it up. So what we really want to do on these when we install them is we want to make sure the installers are looking at pretty much what the length of the line sets are, looking at the chart, figuring out how much we have to weigh in while it's under vacuum, and then turn it on and go with it, because that's what it needs. If one of these units runs low on gas, if you do unfortunately have a leak in it, we don't want the service tech to just go pour a bunch of refrigerant into it, because these things are very, very delicate on charge and you're not going to get it right. I mean, I will say, like everybody does, if I go out to a customer's house and it's 5 o'clock at night and it's low on charge, put a few ounces in it to get it heating or whatever it's doing, come back the next day or the next day, remove all that charge, evacuate it out, do your leak test all over again, find your leak and recharge it by weight. Don't ever try to wing these things, because it's never going to be correct. You're never going to know what this system is doing when you're turning it on, which is much why the reason we can't do normal commissioning on these type of systems. And there's no such thing as like checking superheat or subcooling on one of these. They just need to have the right amount of refrigerant in. It needs to be weighed in. So the best way to avoid ever having to do that is make sure that you do a really good job checking for leaks. It spans back to there. Really good job checking for leaks. These systems are all flared. Good job with the flare. We need to make sure our guys are reaming out the copper, that they're putting a little oil on there when they're running the flare, that the flare makes good contact. Most of all, that they put the flare net on before they do the flare, because otherwise you got to cut it and do it again. I do that every time. So we want to make sure the flares are good, we want to pressurize it, and then we want to check it with a leak detector when we're done. So just go the extra mile and you won't have to worry about any of that. All right, thermostat setup, airflows. All these thermostats on these units have these kind of advanced measure settings. We need to make sure we're actually doing the settings. A lot of times, and we'll find, like, our guys do it once in a while too. 5:30, everybody's kind of loading everything up. They turn the system on, seems to be working right. And when they're filling out the form, it comes back, and I'm like, okay, you guys got out of there at the end? Did you set up the air speeds? Did you set up the airflow and the static pressure properly? And most of the time we get it right. Sometimes we got to go back and fix it, but that's another service call. We don't have to if you just do it on site. So the static pressure adjustments and airflow adjustments are on the thermostats in these units when you're programming them. When you're programming the systems, it's going to walk you through some different settings, and usually they're going to be like a weird code number, like TS1 or TS2, whatever it happens to be. You need to have the instruction book in front of you. What we've done is we've taken a couple of those instruction books and we've highlighted the actual settings for the airflow so that the guys can look at that sheet and tell exactly what we want them set at. So they don't have to like reinvent the wheel every time. The other thing is like leave the instruction manual for the thermostat you use the most. Have an extra one for your truck, so the guys in the truck have it, so you don't have to search for it or wonder where it's at. This is really, really important stuff for getting the right airflow and not having customers complain like there's too much air, too little. Also on the fan on and off cycles too. Some of these units are designed to keep the fan moving continuously even after the end of a heat cycle or a cooling cycle. That's okay on the cooling cycles usually, like the continuous low speed fan. These units do need to sample the air. So most of them have a setting internally that we can turn the fan off. So when it finishes a heat cycle, that the fan turns all the way off. In my house and my particular system, most of the ones we set up, I just have it set for ultra low fan speed, excuse me, in the summertime because it's moving air and you don't really care. But in the wintertime, those drafts can be annoying. Number 5 is check the static pressure. Have your guys actually check the static pressure and make sure we are where we need to be. A lot of like the lower static units, which are getting harder to find right now because of the way that the SEER 2 program is working, they're supposed to be back someday. But high static pressure kills performance, and we need to build our systems to where they're going to have low static. We need to always have a big giant return air can and a big giant return air duct. We use 18-inch ducts even on 18,000 BTU systems, which when I get a new installer in, they go, this is ridiculous, we don't need to do that. Or even some of my other guys, like, we need a 14, or if I see a 14-inch elbow coming into my shop, I'm going, like, what is this for and whose house is this from, right? Why is this on there? And inevitably my guys will say, well, we had to put 2 on. So they're pretty well trained on that. But big ducts and big returns keep the static pressure low, especially when you're going to use those thick filters. And then make sure your ductwork is pulled tight, it's pulled straight, you've got elbows and PH1 boxes or straight throw boxes. Don't use the end connect boxes because they just add too much equivalent length and too much static pressure to the systems. Just be wise about your design. So keep the static pressure down. When static pressure is up, the fan uses more energy, the whole system uses more energy. You're now no longer installing the most efficient solution if you're hobbling its efficiency while you're installing it. You're also going to get less delivered capacity. Keep the ducts short in the attic space. If you're putting in a system for the first time and you're cutting it into the house, keep the ducts short. Every inch of ductwork that's in an attic space or under the floor is going to suffer losses because of the ambient conditions around them. Bury your ductwork in the attic. Do these things that are going to reduce energy flow, reduce static pressure, make the system as efficient possible, and verify it by checking static pressure. So let's try to avoid some callbacks on heat pump water heaters. 5 things you don't need to tell the customer, but you should do every time. One is sizing is critical. This is something I do share with my customers, right? So we have customers all the time. Well, I've got a 50-gallon gas water heater. It's just me and my wife living here. I only need a 50-gallon water heater. I'm like, well, that's good that you have a 50-gallon water heater, but this is a completely different animal. Like, we need to talk about how these systems work and why having a capacity of preheated water is really important with a heat pump water heater. So we talk about this thing with our customers called hot water events. And we talk about sizing these systems and recovery rate. Like a 50-gallon gas water heater has 40,000 BTU burners, most of them. So that means the water can heat up really, really fast when they take a 10-gallon shower. A 65-gallon heat pump water heater only has a 42,000 BTU heat pump in here, and it's got $4,500 or 4,500 watt heat strips as well. Some of them do. We want it to not use the heat strips as much as possible because that uses more energy, obviously. So what we're trying to do with these things is keep a lot of water warm so that every time they have a water heating event, we're using a less percentage of the water. The other thing we want to do is just make sure they understand recovery time. And when we're putting in a 50-gallon gas water heater, that has a first hour rating of 86 gallons. The heat pump has a first hour rating of 67 gallons. That is not, 67 is not as high a number as 86, right? We know that. Noise. Set expectations with your customer from the start regarding noise. Actually, when we do our virtual presentation, we have this picture here, and it has a caption under it that I think says, "Is sound important to you?" What's it? Yes. How quiet is your lifestyle is the way we frame that with our customers. And we just have a slide. It just says, how quiet is your lifestyle? And it's got the little girl with her hand over her ears. And we judge the reaction of the customer, and then we know which way to talk, which way our conversation is going to go on this. But we always set the expectation that these things are going to make a sound. Sound is very subjective. People, if I've got 5 kids in my house and the TV's always on, and I'm not going to hear the thing, right? But if I'm sitting in my wingback chair reading a book all day, and my back is to the garage wall where the water heater is, that person's going to hear that. It's going to drive them crazy, right? People live kind of a more quiet lifestyle. A small amount of sound is a lot of sound. My family, I mean, I couldn't have it in my living room, but you know, being literally where I sit and watch TV, my water heater is directly behind me in the garage, and I don't ever hear it. So, but we need to be able to get this conversation going with the customer, so it's in their mind that this thing's going to make noise, and we can help them advise us on how we need to approach this. So, customers aren't really used to their water heaters making noise unless it's the boiling and gurgling effect that they hear when their gas one's getting older. But and we got to be careful with comparisons too. I gave a comparison to a customer that lives right down the street from me, and he says, well, how loud is it? And I says, well, it's right next to your laundry equipment. It's, you know, you turn on your dryer, it's going to be about the same level of sound. Well, it probably is the same level of sound, but it's a different frequency of sound. So he took that as, when he's running, he says, you told me this was going to sound like my dryer. And I says, no, I said it was going to be about as loud as your dryer. And he says, well, this is louder. And I says, it's the same loudness, it's just different frequency. But so be careful on what you say. A lot of the newer models are much quieter than the older ones, which is good. And there are some things that you can do to adjust that. And we'll talk a little bit more about that in the next section here. Mixing valves, we need to put the mixing valve in. It's a key component. We need to explain to our customers that we're going to amplify the capacity of their system by running the temperature of the unit up, keeping the water warmer, and tempering it back down at the mixing valve. So they're going to have a nice safe temperature that's going to increase their capacity of the system. This is going to give them a quicker first hour recovery. So if I have a 50-gallon water heater and I take a 10-gallon shower and I don't have a mixing valve on it, I've used 20% of the water that I've taken out of that water heater, and then I'm going to be putting 10 gallons of cold water in there. So I've got 20% of the water is now cold going in there. That's going to take a specific amount of time to reheat. If I have a mixing valve and my tank is 150, I'm mixing down to 120, that 10-gallon shower becomes a 7-gallon shower. So it's a lower percentage, which means my machine doesn't have to recuperate as quickly, or it doesn't need, it's going to use less energy recovering because I took less water out of it. So these also will help customers, you know, avoid running out of hot water. I have a 65-gallon plug-in 115-volt water heater at my house. I've had it run out of water one time. I keep it at 140 degrees, and my mixing valves, I tested, it's about 125. So if you do a bunch of laundry and a bunch of showers in one day, you could burn through that. If a customer burns through 65 gallons of water in this water heater, it's going to take 5 to 7 hours to recover. They need to know that. But most people, if they do the laundry and they take multiple showers, they're not going to use the hot water again until the end of the day, or if they do it at the end of the night, it'll recharge during the day. So it's not usually a problem other than getting a small dissatisfaction of a little bit of lukewarm water at the end of a shower. We want to try for that to never happen by tempering the customer's expectations. So we will set the tank temperature higher than you might used to and mix it down. So we talked about that. Okay. Cold air output. We need to talk to him about the cold air output, but we need to not emphasize that there's enough cold air to do anything with, right? So if we're talking to those engineering types and you tell them, hey, we're pulling in the ambient air and we're blowing out cool air, the engineering type is going to want to like put something on here and blow that air into the wine cellar or the house so that they can recover that bit of energy. And we need to let them know that it will be blowing cold air out of here, but this is a very small BTU machine. It's not worth moving this air into somewhere where you're going to use it. But it may be worth moving the air out of where you're putting it. So it might be a good idea to move that air, blow it into an attic space or blow it outside, but it's not worth trying to recover the air. It's just not. This is something that will trigger those engineering types out there to want to figure a way out. And I've seen some pretty convoluted ways to do this. Actually, we did this once for a guy. We put a Y branch on here with 2 dampers, and one damper went out to a duct and the other one so he could blow the cold air out when it's cold in his basement or his garage, and he could blow the air into the garage in the summer. But the thing was really ugly and it probably did nothing. So we just tell people we're not going to do that. So the goal is always to have the unit run in heat pump mode. If the unit is running in heat pump mode, those things are pulling maybe 450, 500 watts. It's very little. It's going to run a little bit longer, but that's going to be normal. But we need to leave the settings when we put these things in the most efficient mode, and tell the customer, like this system that we have designed for you is capable of maintaining all of your hot water needs if we have it set at this temperature and you leave it in heat pump mode. However, if you have people coming in for the holidays, or you're doing, that's a good point right now, the kids are coming home from college for Christmas, go out there and put it into hybrid mode so it can recover more quickly, right? You have this basically turbo overcharge mode that you can access if you need it, but keep it in heat pump mode as much as you can. Sometimes in the winter, if it's in the garage, they're going to have to put it into high recovery mode because of the ambient conditions in the garage, possibly. But you want to let the customers know to run this in heat pump mode as much as possible. It's just more efficient. And also another one here, this thing is going to create condensate water. We need to be careful about where we're running condensate water. Customers, when their water came out of the water heater, out of the little pipe on the side of the house before, most people have never seen that happen. And so they go, why is that happening, right? So, and that would be like a TP valve opening, and they probably see steam coming out and a lot of water coming out, whatever it might be. But now these units are always going to create a little bit of water. We need to put the thing outside. I will tell you, learning from experience, have your technician tell the customer, look, I'm running this line outside, it's going to drip water. Do you have a preference in this area of where we put this? And let them know what that pipe is coming out of the side of the wall, because later on when that drips, if they don't know, they're going to be on the phone with you. So easy way to do that, keep the customer in the loop while you're doing that, and let them know that that's going to be dripping water all over their pathway. Do you want me to run this white pipe down the wall 2 feet to where it goes into the flower bed? 5 things you don't need to tell your customer, but you should do everything. So avoid the inside of the house when you can. Never install one of these units next to an HVAC thermostat. We learned that the hard way. Use ducting if it's going to be in the house to duct it out. If you're going to put a heat pump water heater in a closet, you have to do something with the air. Most of these units need between 500 and 700 cubic feet of air movement space around them. So if you're going to put it in a closet like this, you should be running the outlet of this outside and pulling air from inside. So some of the newer models have duct connections on the top, where what we would normally do, pull air from the side and push the exhaust air up into the attic space through the old flue hole. If we're doing one in a closet, typically that's the way we're installing these. So if you're putting one in and it's inside the house and you have to move it outside the envelope because it's just going to be too aggressively noisy, and you know this customer gasped when they saw the "how quiet is your lifestyle" picture. We know that we want to keep it as close as possible to the water loads. So sometimes we'll take them out of the building envelope, move them to the garage. We've done a few where we've moved them outside the house and built a really nice beautiful enclosure around it, and then vent them out of the enclosure. A lot of times we'll see tankless water heaters on the outside. We have to build enclosures around those. And if you're going to put it in a closet, when we do one of these, we will put insulating board foam around all this, seal all the cracks with foam so it creates a nice little soundproof environment, and then duct them out so that the sound isn't going in the closet. So always good to have a surge protector on these things. We want to make sure that the disconnect is installed in a way. This is a good picture right here. You can see the pink foam board behind all of the wall here that we put in this particular closet application. Want to have the disconnect where you can reach it if you need to. TP valve has to be piped out. You see mixing valve here, unit at 150, insulated lines, soundproofed closet. We want to make sure that if there's a bonding wire on the old one, that we need to put the bonding wire on the new one. Usually the inspector is going to ask you to do it from the existing gas line over to the cold water pipe. If it's not on there, you might want to put that bond wire on there anyway, just so when the inspector comes out, he's not going to say anything, because that's another way to reduce a callback, is not having to go back on permit failures. And we have early on gotten permit failures for bonding wires. We don't do that anymore. Make sure you're not overloading. Electrical load calcs. Do the electrical load calcs on these things. Don't be afraid to put a 110 unit in if it's what's necessary to keep the load down. We had a house recently where we had to do that to keep it under the threshold of the power. So they have 110 volt, 65 gallon, I think, in their house. Actually, we just did one in Napa a couple days ago where code required that one, because it's a 3-bedroom house with 2 baths. It requires on a 115 volt unit to have a specific size water heater. Those codes are out there, but I watch for that too. The TPR and condensate, never want to run these two together. Never want to have the condensate tap into the TPR line. The TPR line needs to be copper, or there's certain types of PEX that will work apparently. We always do them in copper anyway. But these have to drain with gravity. This is not necessarily under pressure. Sometimes these TP valves will just open a tiny bit and they'll drip water into here. Other times, if the thing's about to explode, it'll open all the way. But the TP valve is just to let pressure off. And if this pipe is going uphill, that water will just sit in here, and that's not the way it's supposed to work. So you have to put a tilt on these. Sometimes we have to run these 15 feet in order to find a way to get them out of the house if they're like in a subterranean area of a basement. There is other solutions that we've gotten away with in basement areas, like a cold water shutoff valve and a water sensor at the bottom. They've let us get away with that in a couple of towns because these TP valves are much lower than traditional tanks are. So if I've got a foundation wall that's above this level and it's wrapping all the way around the basement, I don't have much choice. I have to come up with an alternative. That condensate line additionally has to have that 1/4 inch per foot drop. We often install a lot of pumps on these. Even if there's like a sump pump or something nearby, we'll put a condensate pump on here and run it outside just to avoid the possible callback. And then try to terminate that into a permeable surface like a flower bed. And we did one recently where we took the drain off, and we took the drain off the outdoor unit, and we were able to pipe the condensate into that, and all runs into one. And then we dug a little hole and put some pea gravel in it, so it's dripping into that little pea gravel pit. So it may be a way to do it as well. Noise prevention, pick the quietest one you can. So there's different models that do different things on these, and we need to understand too that these are application sensitive. So there's a couple of different brands out there. Some of them have the fan, the blade fan, which are always going to be make a little bit more sound, but they have the blade fan exhausting in the back corner. Some of them have a blade fan that exhausts in the front corner, and some of them have the intake and exit on the top. So we like these particular ones if they're going to go into a closet space because they're easy to duct in and out. And these actually use a blower fan instead of a fan blade. So you can hook up to 100 feet of duct on this. All right. Putting a little bit of soundproofing on the closets is always good too. So here's that, double check the incentive requirements on these. If you're doing a 120 volt system, it does matter in most of the areas. This is California plumbing code. If you have a 2-bedroom house, let's go to a 3-bedroom house. 2-bedroom house, 3 bedrooms, you need 62 gallons of hot water, first hour rating. So the water heaters don't always have high first hour ratings. We have another chart that actually shows what it is, but so some of these are going to need like an 80-gallon tank in order to get this 62-gallon first hour rating. So be careful which ones you install, because if you install it and find out it's not going to be able to be permitted, it's going to cost you a lot. So we have 5 minutes left for any questions. That's our presentation for today. I hope you all out there gathered a little something. If there are any questions out there, Alex?
All right. Yes, we have a couple. So Mary brought up an interesting point earlier, which is worth coming back to. So let me just get back to that real quick. All right. The comment was, what about this as an option for keeping a bedroom cooler while sleeping, closing the vent to the bedroom and keeping the door closed? My comment there was that it's an interesting thought. We try to avoid closing registers most of the time because it impacts the static pressure of the system. But what's your take on that, Larry?
My thought would be, I'm going to base this on how the register in my room works. And like if I had to stand on my bed and close that vent before I went to bed and then remember to open it in the morning, I mean, that would just, for me, that would be, it would be a bit of a problem. I mean, obviously, if you live in an area where it's really noisy, you don't want the window open or something like that, that's something to do. We try to avoid closing the registers if we can, because it can throw off the balance of the system. These systems are pretty delicately designed, at least the ones we do. But if you're just going to turn it off and turn it on in the morning, if you feel like you want to expend the energy doing that every time, I mean, it would be viable as long as you remember to open it the next day so it doesn't throw off the operational capacity for the whole day.
All right. Next question. Do you need to periodically clean out heat pump water heater condensate drains, maybe with a small amount of bleach? This is from Paul.
Yeah, I mean, anytime you've got water standing or going through a place and doing maintenance, the actual drain pan is in the top area of those, so you have to take the top off to get in there to do it. If you're just talking about cleaning the drain line, it's always good to maintain everything as well as you can. I don't think it's part of our procedure when we do maintenance on heat pump water heaters to do that. If it's going into a drain pump, we always clean the drain pump and make sure that the exiting line from the drain pump is nice and clean. But anytime you feel like you should clean something, you should just clean it, because it's always going to be better if you do.
All right. Those were the main questions. Let me just go over a few other items from the chat. Catherine pointed out that since refrigerants are greenhouse gases, minimizing leaks always makes sense, because that'll make it much more eco-friendly.
Absolutely. It's more than just you spending money to go back and fix a leak. It's when we have a leak on a system, everybody that was involved in the installation of that job and the company owner should be like putting their head down a little bit, right? And going like, we caused an inconvenience for our customer. We cost our company a little bit of money to go fix it, but we also like leaked this refrigerant into the atmosphere. Like that should be the point in which we all go, this has been a big problem here, right? So that's a very good point, Catherine. These refrigerants, and when they leak out, they're not really good for they're terrifically bad for the environment, like on an amplified level. So great point.
All right. One last item here. Looks like we're at time. Then we'll hand it out to Javier and close it out. But there was a question. Do you program the thermostat to minimize operation of backup heat strips if they're included, since it's a very expensive option? The initial reply in the chat was that we ourselves, we never install heat strips due to the way we design select our equipment as well as the local climate. But if it is installed, yes, you certainly want to minimize those coming on whenever possible.
Absolutely. And the thing about heat strips, you know, I was a service technician I've been in this trade for like 40 years. Service, what we saw, I lived in Reading for a number of years and serviced up there where it was very cold. And a lot of the houses had heat strips. And one of the things about the heat, what would happen occasionally is the controller that turned on and off the heat strip was a little bimetallic switch. And in line of that was what they called a little limit switch, right? So if the heat strip got really hot, the limit switch would close or it would open and the heat strip wouldn't run. But we would see these bimetallic switches go bad and those heat strips would be on all the time. So anytime air was moving through the system, the heat strip was on and people go, why is my bill so high? And it was because that failed in that way. But that doesn't really have that much to do with that question, but you do want to program that emergency heat to only come on mostly during defrost or when the unit loses significant capacity that can't keep up anymore. But that's also that also can be eliminated by the choice of the equipment you're installing. If you're installing inverter equipment and it's designed right, most of those systems can operate with plenty of capacity if it's sized properly down into the minus degrees. So we don't really need heat strips as much as we used to because of the technology that's available today. So choosing the right technology might eliminate that from being even a factor at all. All right. All right. So thank you so much, everyone. Join us again next week for zoning with heat pumps. It's been great to get in front of you again. We're in a little bit of a different environment today, so if it felt a little weird, and thanks a lot. Have a great day, and we'll talk to you next week.